Okay, welcome to the video on the graphs of trigonometric functions. I know we already talked about the table, but we want to do some refreshing of your memory, and I'm also going to tell you where the background of where these values came from with the basic angles that we talk about on the unit circle. So here's the table again that I've already showed you, sorry. And I want to kind of go through where we came up with. Well, I know you know the 0, the 90, the 180, the 270, and there's 360 below here that are all quadrant angles. So that's, you can see why we need to know those. But the 30, 45, and 60, I want to show you where they came from. So the first way we got these basic values is we're going to talk about a square, because this helps us talk about the 45-degree angle. So if this is a square, okay, you know all the angles are 90. If I drew a diagonal, and it's a right triangle here, so you know this is 45 and this is 45. If I were to have all the sides 1, okay, and since I know this is 45 degrees and this is 45 degrees, it doesn't really matter which one I use to find the values. If this side was 1 of a basic one, if I did a squared plus b squared equals c squared, I would find out that this diagonal, or in this case the hypotenuse of my right triangle, is radical 2. So if I did the sine of 45, and we'll pick this one just for the sake of it, the sine would be opposite over hypotenuse. So the sine of 45 degrees, which is opposite over hypotenuse, is 1 over radical 2. And if we rationalize it, that's where we get the radical 2 over 2. So that's where the 45 comes from, the history of it, okay? Now the cosine of 45, if you'll notice, so let's do cosine of 45 degrees. When we do the cosine of 45 degrees, that's adjacent over hypotenuse, so we're doing the same thing. That's why they're the same, okay? Is going to end up to be radical 2 over 2. So that's the reason why that is the way it is, okay? Now, the 30 and 60 are on an equilateral triangle. So this was based on a square and taking half of the square. These two are based on an equilateral triangle. So let me draw an equilateral triangle. I'm going to erase this so that we can see this while I'm doing it, okay? So if I did an equilateral triangle, and in fact when I was in school, this is how I remembered all these. We didn't really do a table. And if that's an equilateral triangle, if all the sides are the same, okay, is that you know that this right here, if I drew an altitude, it cuts it right in half. So if each side, we'll say, is 2, this would be a 1 because it's halfway. It's a right triangle. And when I do a squared plus b squared equals c squared, this comes out to be radical 3. All right, so I'm just looking at this triangle right here. Both of them would work the same. So by doing this is 90, you know this is 60 degrees, and you know this is 30 degrees because it's cut in half. So if I did the sine of 30 degrees, okay, sine is opposite over hypotenuse, there's our 1/2, okay? If I did the cosine of 30 degrees, cosine's adjacent over hypotenuse, there is your radical 3 over 2. All right? Now let's do the 60-degree angle. If I did the sine of 60 degrees, 60 is opposite over hypotenuse, there's your radical 3 over 2. And if I did your cosine of 60 degrees, adjacent over hypotenuse is your 1/2. Now I want you to notice something. Do you see how these two are the same? The sine of 30 and cosine are 60. Excuse me, the sine of 30 is a half and the cosine of 60 is a half. And look at here, they're the same. Because remember, they're co-functions and they're complementary. So that means their values are going to be the same. That's just a little quick refresher. Now the remainder of this, so I guess this stresses why you have to learn this and have it memorized so it can kind of connect the dots. Now the remainder of this video is talking about graphing. So I've done a graph of sine here, okay? And let's talk about some distinct features of the graph of sine, all right? Now I graphed this where this gave us decimals, but this is pi over 2, pi, 3 pi over 2, and 2 pi. So I'm going around the unit circle once. And you guys learned that sine starts at midline. So let's do what the distinct features are of the graph of sine. Okay, so distinct features. First of all, Sine starts at midline. So it's going to start at the halfway point no matter what. All right, so sine starts at midline. All right. 2. The max of this graph is 1. The min, or the minimum of this graph, is -1. So that's the lowest it goes, unless we move it around, but that's a basic one. A complete cycle is 2 pi, or, if you will, 6.28 radians. So this is where the whole circle, if you were to think of the unit circle, it's like someone cut a pie with a little over 6 slices. So this is kind of what it looks like. I mean, this is not exactly right, but that's what they basically kind of did. It's a little over 6 slices. So there's only a little over 6 radians in a complete unit circle. Okay. The graph of cosine, okay? Distinct features of the graph of cosine. So distinct features are as follows. Ready? The first one is starts high or low if it's inverted. Okay? Never starts at midline. Okay? So basically it starts at a maximum, a max, or a min. The second thing is the max is, this is the same as sine. The maximum is 1 and the minimum is -1. This is for the regular graph of cosine. And again, a complete cycle is 2 pi, or 6.28. Okay? Now there's some definitions that we need to know in order to understand the work later on in the course. Amplitude is half the distance between the max and the min values. Okay, so basically here it's always positive. That's one thing I want you to remember. It's always positive. And you'll sometimes see, let me erase this mark I just made here. Sometimes you'll see that you'll even see the amplitude in absolute values because it's always positive. The period is the time that it needs to execute one complete cycle. Okay, so the period, okay, is 2 pi over my frequency. Right, that's the formula. Now, finding the amplitude, the period, and midline from graphs and equations and graphs. Okay, so first of all, we're going to kind of go through every single one of these, and I want you to stack it. Now, you are going to do this mostly with sine and cosine graphs, and see how you see the amplitude is the first thing. You got sine or cosine. Your frequency, they always use a b for frequency, but this is a frequency and this is a frequency, just so you know. The frequency is in front of your variable. Okay, and m is for midline. All right, so here I've got them stacked and racked, and this is exactly how I want you to do it. Amplitude first. So you got amplitude is how high or low do you go? Okay, so that is the question you ask yourself for amplitude, right? The formula you use is high minus your midline, or you can say your midline minus your low. So there's how you find your amplitude. Frequency is how many do you see? And when I mean that, I mean how many cycles do you see? How many do you see when you're graphing out of 2 pi? All right, 2 pi over my frequency is my period, so we write it this way. Period is 2 pi out of frequency, and this is basically is how long does it take for one full cycle? That's your question. And m is your midline, and the formula with that, it's like the middle, okay? And the formula for this is going to be high plus low divided by 2. So it's like an average, if you will. That's your midline. And your midline is always a line y equals. So be careful. Just don't tell me the number. It's a line that goes halfway through. So it's going to be a y equals line. So here's an example of a couple of them. It says they want us to find the period, amplitude, and midline. So remember, I always have you stack amplitude, frequency, period, midline. So this is what you're kind of thinking when you do this. So the first thing I always do is the midline. All right? And the midline is what's added or subtracted in the front or back. And if you'll notice, there really is a +0 there. So your midline is right at the y-axis. So your midline is the line y equals 0 or your x-axis. The second thing I always do is check your amplitude. Okay? And the amplitude is what's in front of your cosine. Now remember the negative. This means this one. Oh, what's happening? Stop it. I'm sorry, guys. I don't know. I must have touched something. Oops, sorry. Let's go back. That scared me. Sorry about that. Okay, so here in front, my amplitude's a half. Now I see that it's negative. That just means this has been inverted or flipped, if you will, over the x-axis. All right. So remember, the amplitude's never, ever negative. Then you look here, and I see the frequency is 8. So here, if you have an equation, you can always see the frequency. So I always put an e by equation. If you're looking at a graph, you can do the period first. So whichever third and fourth is depending on what you're looking at. So now I'm looking at equation, so I can do frequency first. So the frequency in this case is 8. All right? But they didn't ask us about the frequency, but they want the period. So it's going to be 2 pi over 8. Or pi over 4. So that's how we do that. All right, let's try the next one. First thing we do is midline. Am I adding or subtracting everything after? Oh, so this one actually has been dropped down to. So the midline is y equals -2. In front is my amplitude, and I see that's been stretched 5, because if you multiply by 5, it's been stretched, so your amplitude is 5, so it goes up high. Now it's from the -2, so it doesn't really go up to 5. It's going to go 5 higher than -2, so this would actually go up to 3. All right. In this case, the frequency is 6 pi. So my period is going to be 2 pi over 6 pi, or 1/3. All right. So now let's practice so we can tell that from looking at actual formulas. Let's do it from graphs, okay? Now if I do a graph, okay, I want you to stack and rack your amplitude, frequency, period, midline again. So I'm going to do it here because I kind of, there's a method to my madness. By doing this each time, amplitude, frequency, period, midline. This is kind of how it shows when you have a formula. You start at midline, come up to your amplitude, and then your frequency is shown on your equation. You'll have to use a graph to find your period, okay? So if I look at this, I find the middle. Well, how do you find the midline? Well, it's high plus low divided by 2. So the high here is 7 plus the low, which is -7, all over 2. So my midline is y equals 0. And it looks like, if you were to look at this, it looks like the middle is line y equals 0. So I always kind of draw this here. So here's the midline y equals 0. Now the amplitude is the next thing I do, is always high minus your midline. So once you know what your midline is, or your midline minus your low, it doesn't matter. If I do the high minus the midline, I see my amplitude is 7. So it's been stretched 7. Okay, the period I can tell by looking at the graph. So how long does it take me to see this? So I can see it takes me all the way to here. And this looks like a sine curve, doesn't it? So the period, how long does it take me to see that? And if I count over, I see my period is 8. Now, if I wanted to come and write a formula for this, the first thing I would say at the top is it looks like. What does it look like? Well, in this case, it looks like a sine curve. Okay? So if we were going to do this formula, I say y equals, the amplitude goes first. So we said the amplitude was 7. Looks like a sine curve. Okay. Then we do parentheses. Now we have to do our frequency. Oh, we don't know what the frequency is. Well, if the period is 8, that equals 2 pi over my frequency. Either I can cross multiply or flip their places because they're inverses of each other. You get 2 pi over 8. I see that my frequency is pi over 4. So that goes here, x, and it's at the middle there, so we can keep it right at +0, but we don't need to show it. So right there, that kind of shows you the formula for that. Okay? Now, writing equations from this, we're going to do what I just showed you. This kind of goes through it all, but we do the midline first, and then we're going to practice this. This is just for you to look at if you want to go back and look at things, but we've already talked about this. All right? So we're going to do a couple problems here that actually goes through this. I'm going to let you try this first, so I'm going to stop this video right now, and then I'm going to show the examples on another video. So go ahead and try these first. I want you to do this for each one of them. Looks like, okay, sorry, amplitude, frequency, period, midline. Okay, put equal signs here. Get it set up, and we're going to do the other one too. Ready? Looks like amplitude, frequency, period, midline. Okay, so get started. I'm going to make a little video of this afterwards, okay? So I'm going to stop this right now and see if you can do it.